Hi, my name is Shannon Simpson. Welcome to another Cosmic Convo. From the solar nebulous nucleus all the way to M31 Andromeda Galaxy, our next astronomer has imaged the heavens from right here at Cranbrook Observatory and Cranbrook Institute of Science. I'm honored to have Michael Foerster in my presence. Nice to meet you.
Welcome to the observatory.
Thank you. So, give us a brief backstory on your journey into astronomy.
Well, my dad worked in the Apollo program, so this is something that I always knew I was going to do. I have worked a few places over the years. I retired at NASA's Jet Propulsion Lab as for outreach astronomer, and my wife took a position here in the Detroit area, so here I am at Cranbrook.
All right. That sounds awesome. All right, so straight into the business, all fired up. The sun has had a lot of activity lately.
Sun's been busy. Yeah.
The sun's been very busy. The sun is very grumpy. From your standpoint of observation, what do you see happening with the sun here in the near future, come maximum?
Well, as we're heading towards solar max, which is going to happen somewhere between 2024 and 2025. That's part of the issue, is we're not quite sure exactly when maximum is going to be. The sun does whatever it wants to do, and it does have the 11 to 14 year cycle, but the timeline is a general guideline. It is not locked in stone.
Right.
There's no stone on the sun. So as we are looking at the activity ramping up, trying to decide just how active it's going to be. As you and I were discussing before taping today, the sun has right now a very large sunspot group, the largest we've had in the cycle. That is right now.
354.
Yeah, right now facing the Earth, and has been growing nicely. So as we're looking at activity, we'll keep an eye on it. It is, as we talked about, my favorite star, and yours too.
Yeah,
most
should be.
I would imagine.
It is my favorite star, actually. Even if I did come from another star, I think this is my favorite.
Oh, what star did you come from?
I may have come from Wolf System.
Wolf 359?
You called me out.
One of the wolves?
You know where I think I'm from? NGC 2024.
Oh,
the Flame Nebula.
Sure.
I have a huge connection with that area of the sky.
Well, we are all stardust.
That's right.
Joni Mitchell said so. Must be true.
Yep, we are star stuff. Carl Sagan. So I've got our next question now. Pole shift
on the sun.
Yes. Mm-hmm. What could that bring about? What is the human civilization facing, having the sun's pole shift?
Well, we're talking.
We've heard of, we'll say, events before, of extinction events, not necessarily of humans, but of other life. What do you think about that?
Well, the pole shift on the sun would not be the physical North Pole swapping with the physical South Pole. It's a magnetic poles, and that happens every 11 to 14 years. So that is what the solar cycle is the sun's magnetic polarity flipping. So since we didn't die 6 years ago at the last solar maximum, or 18 years ago at the one before that, or 29 years ago, but the one before that, I expect more of the same. What does concern me is not the sun's magnetic field flipping, but a solar flare. Back in 1859, the Carrington event, we had a massive solar flare that was so energetic that it actually was catching telegraph systems on fire, the high tech of the 1800s, because those long wires running next to the railroad tracks would act as massive antennae, and they would gather the sun's energy and charge up the entire system. If that happened today, we would be messed up. I'd use different language, but we're videotaping, so.
Right, and that would cause a significant problem for satellites.
Satellites would cause a significant problem here on the ground. Whatever part of the Earth is facing the sun at that point, its electrical grid will go down. The large transformers, of which there's only a couple hundred here in the United States, the big transformers, would be fried. And we manufacture 3 or 4 of those per year. So it doesn't take much to see that, there's 200 of them are fried. We make 4. And if the electrical grid is down, how can we ramp up production? The internet would go down. Cars would fry. Maybe the oldest cars, your 67 Bel Air, your old Corvette Stingray, the Corvair, unsafe at any speed, might live through a solar flare.
Wow.
But anything that has computerized electronics in it,
it'd be shut down.
No, like your phone,
Shut down. Yep.
my computer, we would be seriously messed up. Yeah.
Now, also that brings me to the question of the magnetic field of Earth and its weakening to an extent.
Mm-hmm.
That would cause us to have problems with ultraviolet radiation in a sense to where it could get excessive if the problem is not taken care of. What is the problem? What are we looking at?
Well, the Earth has at its core a lead nickel ball. It's rotating, it's creating a dynamo. That's what creates Earth's magnetic field. And every few 70 to 100,000 years, the Earth's magnetic field slowly flips over. It's something that would happen in such slow motion. We would have hundreds of years, if not millennia, to adjust and prepare for it. What can we do about it? Make more sunscreen. Again, this is something that happens every 10 to 20 millennia. It's something, 100 to 200 millennia. And life generally keeps going on. Humanity has been around, Homo sapiens has been around for 150,000 years. We've already lived through this type of event. So it's not something that keeps me awake at night.
Yeah, no.
Carrington event, yes.
Yes, Carrington event.
We don't know. That's a problem with that super flare. We don't know how often that happens. Does it happen every 100 years, every 1,000 years, every 10,000 years? We have a sample set of one. We have seen one such event that caused a technological nightmare for the 1800s. So is that going to happen in the 21st century or 1,000 years hence?
Right.
Don't know.
So not all fully destruction, but just one more question. Asteroids.
Love them.
They're a big issue lately. So we're talking about tracking and characterizing just so many thousands of asteroids, but also I was hearing something about what's called the giggle factor and kind of playing with that death factor of saying an asteroid could come and do this and things like that. So asteroids are like supernatural omens. Let me ask one question. With the last event that we had, the last large, it was known, is that 2013 Chelyabinsk?
Yes.
Russia. It was
I'd call that a medium event.
It was a meteorite.
Yes.
That come through the atmosphere and caused a sonic boom so big it blew out windows for how far? Was it miles?
Yeah.
It had been some square miles.
Yeah.
That's a lot of damage, right? Do you think that humans here in the future, with the technology we have, with the way we're advancing, do you think that we could possibly be able to protect ourselves from such a horrible event later?
Absolutely. And we're getting there. It is, when you're talking about giggle factor, David Levy is a friend of mine. You might have heard of a comic called Shoemaker Levy 9.
Yes.
And David was talking about going to Congress, going to officials at NASA and other science organizations before he and the Shoemakers found their comet, and trying to get their attention, saying, hey, these things are out there, they hit planets, they cause damage. You might want to ask about the dinosaurs. And the joke we have running around the Jet Propulsion Lab is why the dinosaurs extinct? It's because they didn't have a space program. We do.
I've heard that.
And our capability is getting to the point where we might be able to do something about it. But after Gene and Carolyn and Shoemakers and David Levy found Comet Shoemaker Levy 9, found it barreling into Jupiter, leaving scars on Jupiter that were as big as 3 or 4 or 5 Earths, watching this thing disappear. These are fragments of the comet, not even the entire comet. The comet broke apart into 36 large mountain-sized pieces, and they went in and splashed. You could see plumes that were larger than the Earth.
Wow.
And then you could take those pictures and put them on the desk of your local favorite congressman and say, stop giggling.
Stop giggling.
This is a real thing.
Serious.
Yes.
It's a very serious factor. Now, I thought about something as far as getting the public involved in finding asteroids. Do you think that's possible to, get the public involved? Maybe those with larger telescopes maybe know where to look and find these things and probably track them. Do you think the public could do anything for astronomy to help us?
Zooniverse.org. Zooniverse.
Okay.
And that is the problem we have in astronomy is there are more stars than there are astronomers. We have terabytes of data, but it takes time and patience to parse through it. That's where we could use the public's help. So projects like Zooniverse put the pictures up in different, there's galaxy identification, asteroid identification, and other projects. And you can go through, because the human eye is still so much better than AI, and say, yes, planet, planet, asteroid, asteroid not, and be able to actually categorize these things and alert astronomers to say, hey, we found something really crazy here. You might want to take a closer look. So, there's only a few tens of thousands of professional astronomers worldwide. So having the ability to parse that information, to organize it, to say out of these many terabytes of data, you might want to look at these 10, 20, 30 things.
Yeah, that's true.
And the public has been a great help. There's been significant discoveries.
I know that even with the Juno mission, I guess there were ground-based telescopes that did help out with imaging Jupiter for a while.
Yes.
So a lot of people send their images in. I think they still may. I'm not sure.
Yes.
They used to send their images in and then the scope of what's going on Jupiter at certain times, because I'm pretty sure they may not want to watch Jupiter all day and night like some people might. Like I would, because Jupiter is my favorite, not just because it's the largest. But now,
that's third on my list.
Third?
Yeah.
I guess Earth
should
be my favorite.
Earth is my favorite. I'm very attached to it.
Yeah. This is where we are. This is where we
That's my worst
supposedly started.
And Saturn second. Can't beat those rings. All that bling.
That's beautiful. So I hear of an event to say that the rings of Saturn are disappearing.
Yes.
What's that about?
Saturn's rings. Now, I'll tell you what the astronomers' most common answer is. Then I'll tell you where I think it's wrong. It's science. I disagree in some things. But the latest research, based on NASA's missions and the Hubble and Webb Space Telescope observations, is that the rings of Saturn are fairly young. Fairly young, meaning a few 100 million years. Okay, astronomers have a really warped sense of time and distance. But out of Saturn and the Sun and the Earth are all 5 billion years old, give or take. So out of its 5 billion year lifetime, 100 million years, somewhere around 1/10 of the lifetime of Saturn, it's had rings like that. And it's because of a moon or moons that have crashed together, gotten too close, have been crumpled up. Right. That's the common way. My problem with that is the observation that not only does Saturn have rings, but Jupiter, Uranus, and Neptune all have rings as well. Not as pretty.
Right.
Nowhere near as pretty.
Or visible.
Yes. As around Saturn.
Especially Jupiter.
But it would be an incredible cosmic coincidence for all four of those to happen to have rings at the time that we're here to observe them, if they only exist for a few % of the life of the solar system.
Right.
So just under that observation, I think that they've lived longer. No evidence, that's a gut feeling.
Now, moving on to our cosmic disco balls. We talk about globular clusters.
Yes.
We got a beautiful one here in the northern hemisphere. It's
several.
M13.
Yeah.
Not the only one, but M13 is one of the most known. And I love M13, actually. Now, there's one thing I wanted people to understand. Explain the effect of that relative perspective of seeing a cluster like a glob of stars being stuck together, almost thinking the pattern is unchanged. And, when you get a little bit closer to it and you start to see, it'll start to break apart and you start to see, hey, these things are not really stuck together. This is a whole different field.
A
Explain
swarm.
that effect.
It is a swarm of bees. Tens of hundreds of thousands for each of these globular clusters. So a globular cluster is a collection of some of the oldest stars in the entire galaxy. And they look like a ball in space. In fact, you're talking about, this is M13. The M stands for Messier. Guy, I don't know if you've spent other shows talking about Chuck Messier. Charles Messier was an astronomer in Paris, and he came up with a list of the thing. He was a comet hunter. In fact, the French King Louis the whatever called him a comet ferret because he was so good at finding comets. So Messier came up with his list of things that were not comets, but through his crude telescopes of the 1700s, looked like they might have been a comet. So these are the things that I avoid.
Yeah, I had to categorize
they're the most spectacular faint fuzzies in the sky. So M1 is the Crab Nebula in the constellation Taurus. And then he went through his list, 110. And we're talking about the 13th, the Great Cluster in Hercules, which is, yes, one of my favorite things to see.
And is that, what's the distance, the size, and the age of this?
Distance
cluster?
I'm doing by memory, I think is 20,000, 25,000, okay.
Yeah, I have to believe it's 25,000.
Okay, that's about what I expect, yeah. So somewhere in that ballpark. And in that cluster, we argue about how many tens of thousands. It's between 80,000 and 100,000 stars, I believe.
Wow.
So,
that is
all in a very tight area. So if you can try to imagine if there's a planet orbiting around it, and there's probably not many. I can talk about why in a moment. But imagine what our sky looks like if we're away from a big city like here in Detroit.
Right.
If you're somewhere dark, the sky is black. And you see a few stars scattered about, like just twinkling little jewels, just a little bit of glitter. If that's what the sky looks like here, inside a globular cluster, the sky looks like a glitter bomb. Because everywhere you look, instead of being a black sky, you're looking at dozens and dozens and dozens of stars right there. Another dozens or hundreds of stars right there.
You won't be able to tell where you are.
Yeah. Now the reason there's probably not many planets in there is we're talking about these are very, very old stars. They are primarily made of hydrogen and helium and not the heavier metals that we need to make life. Carbon, oxygen, nitrogen, aluminum to make glasses, the iron in your blood. Those elements are largely missing, and we think that those elements are required to make planets. We call that low metallicity in astronomical terms. They're lacking everything beyond hydrogen and helium because they're so old. They're population 2 stars to get slightly technical. So they just they're lacking the materials. But interestingly, back in 1974, we sent the Arecibo message. Are you familiar with that?
Is that from the Arecibo radio telescope?
Yeah. We sent a message to the globular cluster, and we sent it in binary. We had a prime number of horizontal and vertical. We beamed the message there because there was a lot of targets in one place, even though there's probably not a lot of planets per se. Still, if you're looking at 100,000 stars, even if you're looking at 0.1% chance of there being planets, then you could still have thousands of planets orbiting that area.
Wow.
So yeah, we sent a message saying, "Hi, here we are. How are you?" And it'll take 25,000 years to get there and 25,000 years for reply saying, "We're fine, send more Chuck Berry." That's what I expect.
Now, explain to those who may not understand that celestial time machine or look back time for that 25,000 light year distance. Explain that effect of look back time.
Astronomy is time travel because the speed of light is finite. So when we're looking at the sun, we're looking at the sun as it appeared 8 minutes ago. The sun is 92 million miles away. At the speed of light, it takes roughly 8 minutes for that light to get here. So a flare that we see happening now actually occurred 8 minutes ago. If the sun, for some magical reason, stopped, we would take 8 minutes before the light would be extinguished here on Earth. And then the further we go, the greater the lag in time. So when we're looking at Jupiter, Jupiter is approximately 5 times further from the sun than we are. 5 times 8, 40 minutes, give or take, depending on what side of the sun we are and they are. but it takes somewhere around 40 minutes for us to have an idea of what's happening there. Saturn is twice as far as that. So we're looking at 80 minutes, roughly an hour and a half
Wow.
to get back and forth.
Wow.
Pluto, still a planet, I don't care what they say. Pluto is another 4 times further than that. So we're looking at 320 minutes to get a message there and a response coming back. That's just in our neighborhood. Then you get to the very nearest star, and that is 4 light years away. So when we're looking at Proxima Centauri, the nearest star to the Earth, then we're looking at how that star appeared 4 years ago. When we're looking at a globular star cluster 25,000 years away, we're looking at how it appeared 25,000 years ago. It took 25,000 years for that light to be emitted, for those photons to travel through space, and then to come to a nice little toy like this, and those photons that have been traveling for thousands of years to finally pass through the equipment and fall into your eyeball, so you can say, whoa, that's pretty.
Wow.
That's within our galaxy. The galaxy is 100,000 light years across, 100,000 years to see what's happening on one edge if you're all the way on the other edge.
Wow.
Then the nearest galaxy, the Andromeda Galaxy, 2 million years. We're looking at events that happened 2 million years ago.
Wow.
And then the galaxies keep stacking up ad infinitum.
Wow. It's a whole world of galaxies out there, especially when you look at the Hubble Deep Field image. And most don't
Now the Webb
understand
field.
the Webb. Yep, the Webb. Oh, that is much more amazing
Yep.
than what the Hubble has done. And we've actually seen that the Webb has seen the rings of Jupiter. It's seen the ring of Jupiter.
And the rings of Saturn. I
And
saw
the
a picture
rings
of that last week.
Oh,
Gorgeous.
so I have to, and for those who may want to take, you know what I'm saying, a peek at some of those images, where would they go to look at, you know, what the Webb is doing now?
Go to NASA. And NASA.gov, there is a page right on, a link right on the home page to the Webb Space Telescope. The images are downloaded and publicly available immediately. Unprocessed, unfiltered. Some things need some loving. So when we look at astronomy pictures, astronomy cameras, ours included, are black and white cameras. Let me back up 2 steps. So we're looking at your Canon camera. I was admiring that a little bit earlier.
Right.
It has for each pixel actually 3 different sensors. Is it red, blue, green, or is it cyan? I don't know. But there's 3 different colors there. It takes its resolution, divides the resolution into 3 to make the full color spectrum. In astronomy, we would rather have 3 times more data than the picture. So every pixel is black and white, shades of gray.
Okay.
And so for us to get different colors, we take different images and stack them. So if you want a nice full color picture of the Flame Nebula made by the Hubble Space Telescope, Hubble's got to take at least 3 pictures, 4 actually. So it'll take one in just brightness and luminance. Then it'll take another picture with a blue filter, a red filter, and a yellow or green filter. I don't remember which. If you want to skew more infrared, then it'd be different filters instead. And then you have, voila. So the raw data we get back are black and white images.
Right.
Every observatory is
so that monochrome,
Yep.
like you get that monochrome data. that
But
you
using
can
different
select.
filtration so we can look at specific wavelengths of light, because that gives us the data and information that we need.
I've actually modified my Canon camera, actually, my T3. So, yeah, it works much better than it used to. I kind of destroyed the camera trying to modify it. It was a T6i, actually, and I went inside and just missed a few parts. So I kind of destroyed the thing, kind of taking the filter off. But this one was
It was tuition. It was money you spent for an education.
Yeah.
Learn how the camera works.
She knows it's all for science. All for science. Now, let's get down to a big public, let's say, a big public event here, which has been our skies. Seeing UFOs and UAPs, if you want to call them. I want to ask you what you think. Are we alone? Are we alone here on Earth? Are we alone in the solar system? Are we alone in the galaxy? What do you think?
No, maybe, yes. So let's parse that a little bit. Do I think that aliens, after having the technology to travel the distance between stars, something that is so incredibly far, we can just barely send people to the moon. We can't send people to Mars yet. And we talked about those being millions of miles away compared to trillions and trillions and trillions of miles away. Can't even do it. And yet they have that amazing technology and that ability, and then when they get here, they can't park. They crash, they burn. We see aliens biopsies on Fox News. I don't buy that. But I am a skeptic. Show me this stuff instead of talking about it. Everybody in their back pocket has a camera.
That's right.
When we have rainbows or a meteorite, people have cameras on their doorbells. When there's a meteorite coming in, those are regular events. And we all of a sudden have 50, 100, 200 pictures that we can say, oh yeah, now with all these pictures I can put them out and do the math. It started here, it went through there, it was this big, and it's probably landed over there. This is where we're going to look for pieces.
Right.
And yet, nobody has pictures like that of UFOs. So do UFOs know where the door camera is and avoids those? I have seen exactly one UFO. I was at the Cranbrook Observatory. I was doing a public event, and I had a person say, hey, what's that? And I said, I don't know, but it's moving a little weird. The difference is I had a telescope. So I turned the telescope around, and I looked at it. It was a Chinese paper lantern with a candle underneath.
Oh.
And it was floating in a way that was not a satellite, was not an airplane.
It's kind of tricky looking at things in the sky.
Yeah, so it went from a UFO to an IFO. It was an identified flying object. Just because we don't know what something is doesn't mean it's from planet Xenon.
Right.
If we don't know what it is, it means we don't know what it is. So until you bring me better proof, then Carl Sagan, how exactly did that quote go? Is that extraordinary claims require extraordinary proof.
Yep, that's true. So,
do I think that there are aliens here on Earth? There are some people I've met who are pretty alien, but they're still Homo sapiens, so I'm going to say no. Do I think there's a possibility of life in the solar system? Yeah. I've got a $50 bet with a colleague that we're going to find proof of life on Mars by the year 2050. But I'm thinking pond scum would be a huge step. I don't think we're going to get to pond scum level.
Oh, no.
Europa. Enceladus.
I bet on
ocean worlds.
I bet on Europa.
I would think that there's a good chance there, but we're talking about microscopic critters. We are the only intelligent species. Let's make allowances for apes, chimpanzees, dolphins, and the others, but they don't build telescopes. So
that's right.
I'm going to stick with us. But do I think in what is essentially an infinite universe, is there possibility of life elsewhere? I'm going to say, yeah, I think there is. Because otherwise, as Woody Allen, famous astronomer, once said, if there's nobody else out there, we're an incredible waste of space.
That's true. That's understood. Now, we get into the class civilizations because we'll jump into the more scientific part or kind of quantum area to say that there are different classes of civilizations. And I know you heard the theory of the great filter, and are the humans at the great filter? Did we pass it? Or did another life form pass it before we did? Where are we? And they kind of set us in a class of civilization to say that we're low, and other civilizations could harness the power of stars and black holes and the galaxy.
So a type 1 civilization is a civilization that can utilize the entire energy of a planet. A type 2 civilization can use the energy of an entire solar system. And then up and up from there.
Okay. So the higher that number goes, the more power they have over their environment.
Well, energy is what makes things go, literally and figuratively. So if you're going to go travel between stars, we need to have energy that is equivalent to more than what the Earth produces right now. If you want to travel in your lifetime to Proxima Centauri and back, you would need 1 Earth's worth of energy for that entire trip, crammed into your rocket.
And that's our closest star, right?
That's our closest star. And of course, that's impossible.
Right.
We can't do that with current technology. You can get to the point where you can build what's called a Dyson sphere. We've imagined the idea that you can actually planets and asteroids, obviously you're talking about a very advanced species, and they break these planets and asteroids apart into their components, and they actually build a sphere or a series of rings around their star. Solar panels lining the inside, they capture the entire energy output of a star. So here on Earth, we can capture one Earth surface worth, half of Earth, the half of the Earth that's facing the sun at that time. So imagine millions of times more.
Right.
But interestingly, a Dyson sphere, as much energy as you collect, this heat energy still has to radiate off. It becomes, instead of a visible star, an infrared star. And we've looked for very strange, very bright infrared objects that might be Dyson spheres. Not found any.
Ah, yeah. So it's just a sort of purely imaginative part, just for now.
All of it.
Just for now.
The problem we have with talking about life and civilization is we have a sample set of one. We know of one place that has life here. We know of one technological species, us. And until we find number two, then we can't, it's guesswork. It's not science. Yeah. So when I say that I feel in my gut that there's life elsewhere out there, that's not based on any particularly good science. Although we're getting closer and closer. And you can see the gray in my beard, I've been doing this for a long time. When I was a young astronomer, we didn't know of any other planets outside of our solar system. Starting with the discovery of 51 Peg, 51 Peg B in constellation Pegasus. We've now found thousands of worlds, and based on our discoveries, we think that there is basically a planetary system around basically every star out there.
Wow. Wow.
So out of the 200 million stars that make our Milky Way galaxy, there are trillions of planets. There are 40, 50, 60, 70 million Earth-like worlds.
That's deep.
Use Earth like those. It's about this size, but has kind of an atmosphere. It's about this distance. Doesn't say anything about life or anything else. Venus is, by this definition, an Earth-like world, and Venus is pretty nasty.
Oh,
but that's at least our starting point. We didn't know that 30 years ago. So as we go along, as we figure out how stars are formed, how long they last, those are old discoveries. Now we're discovering that they're planets and how long they last and what they can do. Then we start, is there life on those worlds? And things like the Webb Space Telescope, looking for signs of life, finding a planet with a lot of free oxygen in its atmosphere. Oxygen is very reactive.
Yes.
Something needs to be creating it fresh every day. If you find oxygen in its atmosphere, that might be something like photosynthesis.
So that would be a signature of some sort.
So we're still a long ways. That's still on that list, but we need talking about technologies, finding other civilizations until they put up their version of the Arecibo radio telescope and beam that message reverse from M13. We're talking about the Arecibo message.
We need another Arecibo. We had an unfortunate accident.
You're going to make me cry on camera.
And I was going to, when I heard about it, I actually wanted to go to the telescope. And as soon as I'm thinking about it, because a lot of things actually passed, like maybe I wanted a chance to meet Sir Patrick Moore, but
he passed away.
Yeah.
You're too young to have met him, I think, aren't you?
No.
Okay, sorry.
He only passed away just a few years ago. Actually.
Okay. To me, everybody looks young. What can I say?
Yeah. So I want to ask a question that personally I thought about, and sometimes I think about, like, it's just so much bigger than anything else we think about. Planet size and star size and life size comparison. Say if there is a much larger star, which there are larger stars.
Mm-hmm.
Some of those end their lives pretty quickly, so you may not have a chance to be able to see any life or have the chance to fuse those elements together. But those who do have large planets, large Earth-like planets, what is the possibility of there being life there large enough to make us look like ants?
We have a sample set of life of one. Your imagination is as good as mine. If you want a scientific answer, you got to use, I understand, a Jersey accent for this, and that is, I don't know. I don't know. We don't know. We just don't know. Now, we can make educated guesses, but that's not terribly scientific.
Right.
So, is that a possibility? Yes. And what is, for all intents and purposes, an essentially infinite universe, could that have happened somewhere, sometime? Sure.
All
Why
right.
not?
Right, like in your imagination, why not?
Sure.
Now, let's jump to gravity too, because we want to touch on what exactly gravity is, because it's misunderstood, and I think that a lot of scientists probably still don't know what gravity
Oh, no,
is.
we don't.
We're coming toward
We know how
gravity waves.
we know how
now.
gravity works. We know gravity is a distortion of space-time. But what is the force or particle that actually conveys gravity? Is there a graviton? I don't know. But also, in all fairness, just like medical doctors have their specialities, you're asking a question if you're asking a cardiologist, what do you think of this particular type of bone cancer? And the cardiologist say, yeah, I heard about that, and blah, blah, blah. Well, I'm not terribly familiar with gravitons and curved time-space continuums and Einsteinian relativity. I mean, I read up on it, I've got an idea, but that's not my area.
Just not the forte. I just thought I'd
I
ask
like
because
rocks.
I think about
I like planets.
and one of the things about these interviews is a lot of times I like to get the astronomers' independent thought on what they may think about that subject, because yeah, you have to play it by the book when observing and getting data, but you also may have a different thought from everybody else to think that maybe there is another force behind what's going on. But when observing, you still play by the book, you know what I mean?
Oh, yeah. Well,
So, yeah.
science is...
Because nobody will accept the data if you input what you think it is.
Why would they? They can read science fiction from somebody else just as easily. Yeah. The reason that science is such a powerful tool as it is it's a way for us to not fool ourselves. Richard Feynman said that. There is a real propensity of people I was going to say in science, but in basically any field. If you are really smart and knowledgeable in your one area, things you know a lot about, planetary astronomy for me. For me to have opinions in others, I could sit there and I could pontificate. I am an astronomer, and this is what I think is happening with the Higgs field. But it is the full spectrum of the quark plasma and blah blah blah. And I'm making up stuff as I'm talking. And because I'm an astronomer, wow, he really knows what he's talking about. And I just know. But if you want to talk about rings around planets and why I think Pluto is still a planet and that stuff, then yeah, I have informed opinions. I have minority opinions, but I have at least the data to back those ideas up.
It's been an awesome interview with Mr. Michael Foerster here. And my name is Shannon Simpson once again. And this has been another Cosmic Convo. Thank you for watching.
Thanks, man.